With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi friends, the question is calculate the lattice enthalpy of MgBr2, that is magnesium bromide, from the given data. So here they gave a given data for delta H formation, enthalpy of formation value, and the formation of the magnesium solid to gaseous. So magnesium gaseous to gaseous state, and then bromine liquid to gaseous, and then gaseous to gaseous, and then finally if you see here, the equation will be Mg2 plus gaseous state react with bromine minus, which is also in gaseous state, and form magnesium bromide, which is a solid. So for this reaction we have to find out the lattice enthalpy value, that is del lattice H. Okay, so what do you mean by lattice enthalpy? Lattice enthalpy is nothing but the energy released when a solid is formed from its gaseous ion. So when its gaseous corresponding gaseous ions combine to form a solid compound, then there will be release of some energy. So that is called as lattice enthalpy. The energy is called as releasing energy is called as lattice enthalpy. So, and the last 5 thermochemical equation to the thermochemical equation corresponding to the lattice enthalpy to get the thermochemical equation for the formation of magnesium bromide solid from its constituent element. Finally, calculate delta lattice using the concept of Hess law. Okay, so by using Hess law, we have to find out the lattice enthalpy. So what do you mean by Hess law? Hess law is nothing but the change of enthalpy in a chemical reaction regardless of the steps. It may be several steps or different steps. It will not mind about the steps, but the enthalpy change will be remain constant in the reaction. Okay, so that is called Hess law. So by using Hess law, we have to find out the lattice enthalpy of the given reaction. Okay, so let me write the general equation. Mg2 plus, which is in a gaseous state, combined with 2 moles of bromine minus, which is in a gaseous state, to form magnesium bromine. So what will be the energy release? That is lattice enthalpy. So lattice enthalpy for the del H. So we have to find out the lattice enthalpy for this particular reaction. So we have to take the given data as, so this is delta H formation. Okay, so this is not delta 1H, this is delta H formation. So it is actually a delta H formation can be summed up by using this equations 1, 2, 3, 4th equation, and then this one 5th equation. So by sum up all these equations, we can find out the delta H formation. So by finding the delta H formation as well as by applying that in delta H formation equation, we can easily find out the lattice enthalpy. Okay, so here delta H formation from Hess law. So Hess law is nothing but it can have several steps, but the change of enthalpy is same. Okay, so the delta H formation will be equal to del 1H0 plus del 2H0 plus del 3H0 plus del 4H0 plus del 5H0. Okay, that is nothing but the summation of equation 1, 2, 3, 4, 5. Okay, so this is delta H formation. So delta H formation, what is the value of delta H formation? So minus 524 kilo, everything is in kilojoule per mole, so we can take the number only. So minus 524. So delta H formation is minus 524, and here we don't forget to add the lattice enthalpy del LH. So we are going to find out the lattice enthalpy. So del H formation will be minus 524. So that will be equal to, first equation value is 148. Okay, so that is 148 plus del 2H, second equation 2187 plus del 3, third equation is 31, and then fourth equation. So fourth equation is 193, and then final equation, fifth equation is minus 662 plus del LH, that is lattice enthalpy value. So from this value we can easily find out the del LH will be equal to, so the whole value will be shifted towards the equivalent, so equal to, okay. So when it shift to left, then delta lattice enthalpy value will be equal to minus 524 minus the it will be shifting to right to left, so it will be minus, so plus 148 convert into minus, and minus 2187 and minus 31 minus 193, and this is plus because it has minus value. So when it shift towards the left side, then it is 662, okay, plus 662. So by simplifying the above numbers, we will get minus 2421 as the lattice enthalpy value, okay. So which is kilojoule per mole, kilojoule per mole. So the answer will be, the lattice enthalpy value will be minus 2421 kilojoule per mole is the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubt and App today.